So hi everyone, I'm Kara Erickson. I'm a developer on the Angular team, and I'm here today to talk to you about Angular form validation. So we're going to start with an overview of validation basics, and then we're going to jump into a quick demo of how you might set up basic validation today, and then I'm going to give you a sneak peek into some upcoming features. So let's get started. So when you think about validation, you probably think about something like this. The user types into a text field, and you run that value through your validation rules to see if it's acceptable. If it is, great. If not, you can surface a helpful error message to the user so they can correct their input. So how might we implement this type of validation in Angular? So for every form control element in the DOM, there is a corresponding form control object in Angular that represents that element's state. That form control object has a number of properties that are useful for validation, such as the value. And it can also allow you to configure validation rules to determine whether or not you should show error messages. So when we talk about validation rules, what we really mean are validators. Validators are just functions that take a form control instance, usually looking at its value, and return a map of errors or null. And then we can use this validation result to calculate the status of the control. So if you return null, we calculate a status of valid, and if you return errors, we know that it's invalid. So we have a number of built-in validators that you might be familiar with, like required and min length and max length, but we also allow you to build your own custom validators, and this can be a really powerful feature. So here we have a really important validator function called tambourine validator, and it just checks to see whether the control's value is tambourine. Useful. So if it is, great, we'll return null, which will translate to valid. And if it's not tambourine, then it'll return an error map with some helpful information, and that will translate to invalid. So one thing you might wonder is, why don't we just return true or false from these validator functions? Well, the short answer is that it comes in handy to return error maps when you're composing multiple validators. So if you have multiple validators, you need some way to match a validation function failure with a specific error. So if you have the function just return the error, it avoids having the developer create some additional structure to match the two. Error maps also provide extra information to developers who are building the UI, the error message in the UI. So here we have expected and actual, and you can build that into your message. This comes in really handy with custom validators because you don't have to return this expected actual format. You could return anything. You could, under Tambo, you could return the actual error message string if you wanted, if that's easier to build your UI that way. It's totally up to you. So some cases you have server-side validation, or you need to check some value on the server. And for that, we have async validator functions. These are also just functions, so they take a form control instance, and instead of returning a validation result, they'll return an observable or a promise that will emit validation errors or null. So the classic example of this is a validator that's going to check whether a given username exists on the server. So here we just have an HTTP GET request that goes to some endpoint, and then we map the result into the correct format, which is errors or null. So if you've used async validators before, you might have run into the case where if you had a continuous stream, that the errors are never emitted. That's because you have to make sure to complete your observable. So http.get is great because it completes after it emits the response, so don't really even have to think about it. OK, so now we're going to jump into a quick demo of how you might set up basic validation. So I've set up a sample project with the CLI. I'm calling it bitter, which is uppity, given that it's 2 cards. But it's an auctioning website, and there's 2 inputs. You can put in your name, your bid value, and then the bid will show up on the left. And you're bidding on some imaginary object, like a switch, let's say. OK, so I've scaffolded the application with material. I have some cards here, and I have 2 HTML5 inputs. You'll notice I'm not using material inputs because recently we added some validation helpers that make this too easy. And so we want to start from scratch. So we have, we're using the reactive forms modules, so we have our form group and our form control names here. And then in our TypeScript, we have, this is odd formatting, oh, there we go. In TypeScript, we have our form group and our form control instances already created. And I've also created a few getters to make this easier, and I've set up an API endpoint so we can actually post the bids. OK, so if we were to set up validation for this form, we'd start when we instantiate the form control. So let's say we want to add the required validator to both of these. Oops. And that's just going to make sure that each of these have a value. And to see if this is actually working, in our form, we can go ahead and print out the errors that we're getting. So here we have name errors, we have our bid errors. Okay. So we start with initial error state, right, because they're empty. So as soon as we type into it, the errors will disappear. Cool, so that works as expected. Obviously, with a real UI, we can't have these ugly printouts. So let's go ahead and implement some error messages and some validation styles. So this looks more like a real form. So to start, if we inspect either of these inputs, I don't know if you can see this. Ooh. Yeah. You can see that we have some classes here that have been added by the form directive. So we have ng-dirty, ng-valid, ng-touched. And these are just mirrors of form control properties. So if you were to change this to an invalid state, you can see that the classes update to ng-invalid. This is super handy if you want to style inputs based on their validation status. So if we go into our CSS here, we can just say that if the input is invalid and touched, we're going to add some border here. And if it's valid and touched, we can add the opposite, so we'll set green. Okay. So we also added a touched verification here, so it's not going to have any colors to start with. We're going to wait till the user interacts with it. So initially it's gray, then we blur it and it's red, we blur the other one and it's also red. So cool, it seems to be working. Okay, so now let's replace these printouts with actual error messages. So in here we can remove these, and we're going to create dibs for our errors, and we only want to show these errors if the name is invalid or if it's touched, and it's touched. So it's the same logic. So we're just going to write name is required. And then here we're going to do the same thing with bids. So we want to check that bid is required and touched, or invalid and touched. Okay. So I think that's reloaded. Okay, so here we have the errors. So pretty straightforward. So you can see it's pretty simple to set up basic validation using our built-ins. What about custom validators? So given that this is supposedly a bidding website, we want to check that the bid that you're entering is higher than the latest bid that comes from the server. So you're not bidding $3 when it's a $200 item. So we can create a custom validator for this. So in our TypeScript, we can go ahead and create a minimum bid function. So if you remember, validators take a control. And in this case, it's an async validator, so it's going to return an observable that emits validation errors or null. And we want to check on our server. So we already have this GET request to print the bids that already exist on the left side of the screen. So we're just going to paste this. And we don't want all of the bids, right? So we can map it so that we're only looking at the last bid. And then from that bid, we can map it into the correct error format. So here we can say, hey, if the control value is bigger than the bid, we're good. If not, let's surface this too low error, and we'll pass through some good information like the expected bid. And we can't forget to pass this in, so it'll be the third argument. And we're binding it to this because internally we're using some state. Okay, and then in our HTML, let's go ahead and add an error message so we can see that this is working. So now that we have two errors here, we have to be a little more specific. So we're going to show this ng if the bid has the required error, which we're going to spell correctly. And then if it's too low, we want to show a different message. Oops. So let's say bid is too low. And we can use some of the information from the expected value that we passed back to build this error message. So we can say the minimum bid is, oops, bid.errors.tooLow.expected, I think I called it. But your bid was only, and then we'll just put the bid value here. Okay. Let's see if this works. So we put in $3. We know that's too low. Bid is too low. The min bid is $10, but your bid was only $3. And we can check that this is working by, hooray, it's an error message. Okay. So, and we can check that this is still working. You know, we can put something else here, like just put like $12. And once we refresh, we should have $12. Okay, so now when we put in 3, or when we put in 11, this should now, since it's updating, right, it should still error. Okay, so hopefully that gives you a sense of what it's like to set up basic validation. We don't have time to go into a whole lot of detail, but we do have time to talk about some upcoming features. Hooray. So huge disclaimer. So these are features that are still kind of, they're going through the design review process. We have a design doc that's been approved, but the syntax is still subject to change, so just kind of take away the big ideas and don't worry about the rest. Okay, so let's circle back to what's actually going on when we're typing in that bid input to help us understand how these new features are going to change things. So when you type into the bid input, the sync validators are going to run, and so that's validators.required. If you have a required error, then the errors are set immediately. The status is set to invalid, and we don't even bother running the async validator because we already know that the status is invalid. If the sync validators pass, so you actually have a value, then we run the async validator, so the minimum bid server request. While it's in progress, we set the status to pending. And then whenever the request comes back with a validation result, then we set the errors accordingly and recalculate the status. So that's pretty straightforward. So if we were to make this a little bit more concrete, let's show how a life cycle of how the value gets to the error state. So if we start with an empty string, then the form control goes through validators.required, and obviously it's going to return the required error because it's empty. So in that case, the errors will be set immediately, and the status is set to valid. Then let's say you type a 3 in the bid input. So the form control, once again, goes through validators.required. In this case, it's null because it has value, in which case the minimum bid request will go off. And in this case, it's lower than 12, so you'll see the too low error, and the status is still invalid. And in the last case, you got a 1, goes through all the validators. In this case, everything is valid, so you're cool. So in this way, we're thinking about it from kind of top to bottom, from one value change all the way to a status being calculated, but you can also think about it from left to right. So if you think about it that way, it becomes clear that you have these values that are arriving over time, right? So you have this stream of values. And this stream of values kicks off this stream of form controls that are passed into validators.required. And validators.required returns a stream of synchronous errors. And eventually, once it goes through the async validator, or not, depending, we get this stream of async errors. So you might start to notice that this looks a little bit like an ERICKSJS marble diagram. That's because that's the point. So if you don't know what a marble diagram is, it's essentially a way to visualize observable streams. So we can visualize our entire validation process as an observable stream that's just kind of being transformed over time. So if we were to translate this into ERICKSJS operators, we might have a value stream that's being mapped to a form control that's being mapped through our validator function to get our validation errors, that's being switch mapped through our async validator to get the final validation error state. And then when we subscribe, we can set the errors based on whatever errors are being emitted from the stream and calculate the status. So if we were to pseudocode this, kind of make it more concise, we have value changes that map to the control that, once again, the control maps through the validator function and returns synchronous errors. If there are errors, we switch map to an observable that completes immediately so that the errors are set right away and the status is invalid. Otherwise, we'll switch map to subscribe to this async validator, and then whenever the async validator emits an error, that's when the errors will be reset. So you can kind of see that we're shaping up this process where whenever errors are emitted or null is emitted, we set the status accordingly. So you might wonder, where did pending go? Well, we could also have some sort of pending token that the status calculator internally understands. So if you emit an error of pending with that token, we'll set the status to pending. And you can use the start with operator to kind of prefix your async validator stream. So pending is set out immediately, and then whenever the validation result comes back, it'll override it. Okay, so why do we care? So why do we care about visualizing our validation pipeline as a stream? Well, it opens the floodgate for a number of features that have been highly requested by the community. So one of these is custom validator chains. So what's a custom validator chain? So if we go back to our validation pipeline here, we have all of this logic in the middle. That's kind of our default validation logic, right? It has to go through the sync validators first, and then it's only going to run the async validators if the sync validators pass, and so on and so forth. But what if your application had different needs? What if you could just take our whole chunk of the chain out and insert your own validation chain here? Well, you can do that. So there's an operator called let that takes a selector function. So basically, it's a way to mix in reusable middleware in existing observable chains. So it takes a function that takes an observable and returns an observable. So if you look at an example here, this one takes an observable and returns an observable that's been mapped through validators.required. So this is functionally the same as if you just mapped it through validators.required. It flattens it into the existing chain. So this is a really powerful thing, right? If we can surface this selector function to developers and allow them to configure this function, basically what that means is your application can decide your validation logic from the time values change to when the status is set. So you have complete control over the order and the timing of your validation. So you can debounce things, you can gate your validation running on whether or not certain controls have been touched or your form has been submitted. You can run your async validators first, go crazy, whatever you want to do. And it also means you can emit errors as frequently or as seldom as your application requires. So this opens up a huge opportunity to have low-level customizations if that's what you need. It also opens up the possibility for push-based validation. So if you go back and look at our minimum bid async validator, this is really kind of a pull model, right? So every time the value changes, we pull a new minimum bid from the server because we know that's at the point that we need it. But what if you type a bid in and then you go make some breakfast and you come back and someone has bid on your item in the meantime? Well, you don't get an update, right? The validation's already run, you're kind of done. But if we have this continuous stream of errors that's coming out and we don't require completion anymore, then you can get push updates. You can get real-time validation. So I'm going to show you some of these new features. We don't have a lot of time left, I don't think, so can't show them all. But let's start by refactoring this into a chain. So we're here in the bid validation pipeline here, so we can add a chain. We're going to call it this.mychain. Okay, and then we're going to write it here. Oops. My chain takes an abstract control, and it returns a validator chain. And remember, we're passing through that selector function. So it's a function that takes an observable and returns an observable. So we'll start simple. The observable that's going to come in will be emitting a control. So we can just map that control through validators.required. Oops. So this should work exactly the same as just passing a required validator. So if we blur this, hooray, bid is required, it's exactly the same. Okay, so let's make this a little bit more mature. So we can make this work a little bit more like our default validation chain. So let's say we take the errors from the sync validator. If they exist, we can switch map to an observable that will emit those errors immediately. And then otherwise, we can switch map to the minimum bid async validator that we already created. And if we want to make this really like the default, we also want to start with a pending status. Okay. Do I have my parentheses right? Okay, cool. So when this updates, as soon as we blur the field, we should see the too low error that we got before. So we do not see that. So we're going to check to see what's going on here. Okay, so we have my chain. It's mapping the validators.required. If there are errors, okay, so you know what? We should look at our HTML and make sure this is right. If it has the error too low, the bid is too low. Okay, this will be some exciting live debugging. Okay, so let's go ahead and print out some stuff here. So return, if there are errors, we're going to return observable of errors. And, oh, it is required. Wait, I'm stupid. Okay. There's nothing in there. Okay, so let's refresh this and just start over. Okay, so we put a 3 here. Okay, it's working. Hooray. Okay, so okay, so bid is too low, the minimum bid is 12, but yours is only 3. Okay, so that's still working exactly the same. But you might notice, actually, if we start to increment this value, I don't know if you can see this on the, you can see that flash, right? And the error is flashing, the styles are flashing, and that's because we have this pending status in between valid and invalid, right, while the async validators are running. So in our case, we don't really want this pending status. It kind of messes up our styles, and we're not using it for anything. So since we're using a chain, we can kind of decide we just won't have a pending status in our chain. So you can delete this. And then once this recompiles, if we start incrementing the value again, you should see that the flash is gone. Okay, so you put a 3 in here, blur it again, and now you see that the flash is gone, right? because you can totally customize that. Okay, so the last thing I want to show you very quickly is how push-based validation might work. So instead of using this HTTP module, instead we can use Angular Fire. We're going to make this a firebase list observable. Seems duplicative. Yeah. Okay, and so instead of using this http.get, we're going to connect this up to the Firebase database. And we're going to make this post also work that way. So we're just going to push from the value. Don't worry about the syntax so much. I'm just really quick setup. OK. So in our async validator, we're going to remove this get request that completes immediately. And instead, we're going to have this.bids, which is an observable from Angular Fire that will emit whenever your bids array changes. So theoretically, if we were to create a second instance of this, we can remove this. OK. Screen's bigger. OK, so let's say we put something here like ng-conf. We'll put $20. And at this point, it's totally valid because it's higher than 12. And then we put something like ng-conf2, put $25. OK, so these are two separate users using our bidding website. They're bidding on the same thing. So as soon as we post the bid on the right side, we should see an immediate real-time update on the left side because we have this stream of errors that's constantly being updated. So as soon as we post this, you can see on the left, we have this update in real time. So you can see how this could be really cool if you had, a real bidding website where, bids are coming fast and hard and, it's like updating. So we're really excited about this new feature. That's it for the demo. But if you wanted to find out more about it, we have a design doc that we just made public. And here's some more resources for forums if you're interested. So thank you very much.